Hello friends, today we discuss the most important theory of this chapter. The question will be like this: give the characteristics of the electromagnetic waves, right? So friends, you have to remember this characteristics of the EM waves, right? So first point is the electric field and magnetic field are perpendicular with each other, and also it is perpendicular to the propagation of the electromagnetic waves, right? So in first characteristic says that the electric field and magnetic field are perpendicular with each other, and this both EF and MF are perpendicular with the direction of propagation. So if I say if the direction of propagation in Z axis, then electric field will be in X axis and magnetic field propagates in Y axis, right? Because electric field, magnetic field are perpendicular with each other and both are perpendicular with the direction of propagation of EM waves, right? So see friends, first point, in electromagnetic waves, electric field and magnetic field are perpendicular to each other as well as perpendicular to the direction of propagation. As I say, right, if the direction of propagation of EM waves in Z axis, then electric field will be in X axis and magnetic field will be in Y axis. So see, let EM waves propagate in Z direction varies according to the sign function, then electric field and magnetic field, say Ex, so electric field will be in X axis and magnetic field will be By. So Ex and By both are perpendicular with each other. So here the EM wave propagates in Z axis and varies with the sign function. So the equation of electric and magnetic field will be given by Ex, that is electric field, equals to E0 sin kx minus omega t, and By that is equals to B0 sin kx minus omega t, where k, that is known as the wave vector, and the formula of k wave vector is 2 pi by lambda, and omega by k, that is equals to wave speed c. So here we can write omega is equals to kc, right, or you can say sec k. We already know that omega is equals to 2 pi f is equals to c, and value of k 2 pi by lambda, so 2 pi cancel, so we get c is equals to lambda f, right? So this equation will be used in the example, right? You have to remember, and you already know, right, that c is equals to lambda f, right? So once again friends, characteristics of EM waves. First point is electric field and magnetic field both are perpendicular with each other, right, and also perpendicular with the direction of propagation of the EM wave, right? So if the electromagnetic wave propagates in Z axis, then electric field will be in X axis and magnetic field in Y. So if the EM waves varies with a sign function, so the electric field and magnetic field given by E0 sin kx minus omega t, and magnetic field B1 B0 sin kx minus omega t, where k is wave vector, that is equals to 2 pi by lambda, and we already know that omega is equals to 2 pi, right, and omega by k, that is equals to wave speed c, so we can write omega is equals to sec k, but omega 2 pi of c as it is and k 2 pi by lambda, so 2 pi cancel, so we get c is equals to lambda f. Third point, electric and magnetic field are related by equation E0 by B0, that is equals to C, or you can say E by B, that is equals to C. right? So E0 by B0, that is equals to C, or you can say E by B is equals to C. So you can write E0 is equals to C into B0, or B0 E0 by C, right? So the relation between electric and magnetic field will given by E0 by B0 is equals to C, or you can say E by B, that is equals to C, right? Then the oscillation of electric field and magnetic field, medium not required, right? So for propagation of EM waves, we can say that medium is not required. So we can say that electromagnetic waves are transverse and non-mechanical waves because medium not required, right? Then the speed of electromagnetic waves in free space or vacuum, that is equals to 3 into 10 raised to 8 meter per second, and it is given by the formula C is equals to 1 by square root of mu 0 into epsilon 0, right? So the speed of EM waves, that is equals to 3 into 10 raised to 8 meter per second, and the formula of the speed of EM waves, that is equals to 1 by square root of mu 0 epsilon 0. Next one, Hertz shows that the EM waves, or you can say electromagnetic waves, experiences the diffraction, then refraction and polarization. Right, we already discussed about this diffraction, refraction and polarization in chapter 9 and 10, right? So Hertz shows that the EM waves experience the diffraction, refraction and polarization. Then this electromagnetic waves transmit energy and momentum, right? So energy and the momentum will be transmitted by the EM waves. Next, the electromagnetic energy density for EM waves, that is equals to rho is equals to 1 by epsilon 0 E square, right? So the energy density of EM wave, that is equals to rho is equals to epsilon 0 E square. How we can prove this relation? So see here, the EM waves consist the electric and magnetic field. So the energy density of the EM waves, that is equals to energy density of electric field plus energy density of magnetic field. We know that energy density for electric field, that is equals to 1 by 2 epsilon 0 E square, and energy density of magnetic field, that is equals to B square upon 2 mu 0, right? So rho is equals to rho E plus rho B. Rho E, that is equals to 1 by 2 epsilon 0 E square plus rho B, B square upon 2 mu 0. But we know that here we have to prove this equation in terms of electric field. So we know that E by B is equals to C. So we can write B is equals to E by C, where C 1 upon square root of mu 0 epsilon 0, right? We already discussed this. C is equals to 1 upon mu 0 epsilon 0, right? So to derive the relation between E and B, we know that E by B is equals to C. So B is equals to E by C, but C is equals to 1 by square root of mu 0 epsilon 0. So we can write B is equals to E into square root of mu 0 epsilon 0. So B square, that is equals to, here we can write B square, that is equals to E square. Here square root cancel, so mu 0 epsilon 0. So here we can write B square is equals to E square into mu 0 epsilon 0. Here we put this value of B square in this equation. So we get rho is equals to 1 by 2 epsilon 0 E square plus value of E square, that is equals to E square into mu 0 epsilon 0 divided by 2 mu 0 as it is. So here mu 0 cancel. So we get rho is equals to 1 by 2 epsilon 0 E square plus 1 by 2 epsilon 0 E square. So we get the energy density for EM waves, that is equals to epsilon 0 E square, right? So the formula of electromagnetic energy density for EM waves, that is equals to epsilon 0 square, right? Why? Because we know that EM wave consists the electric and magnetic field. So the energy density of EM waves, that is equals to energy density of electric field plus energy density of magnetic field, right? So rho E 1 by 2 epsilon 0 square and rho B square upon 2 mu 0, right? But here we have to prove this equation in terms of electric field. So here we have to prove the relation between E and B. So for that we know that E by B is equals to C. So B E by C, where C 1 by square root of mu 0 epsilon 0. So we get B is equals to E into square root of mu 0 epsilon 0. So here B square is there. So B square is equals to B square, square root cancel. So mu 0 epsilon 0. So here we put the value of B square. So mu 0 cancel. So we get energy density of EM wave, that is equals to epsilon 0 square. Next, when the electromagnetic waves collide on this surface, it exerts a pressure on this surface which is known as the radiation pressure, right? So when the electromagnetic waves are collide on one surface, then what happens? It exerts a pressure on the surface, that is known as the radiation pressure. Next, we know that sunlight is the EM waves, right? Electromagnetic wave. So we can say that EM waves carries energy from the sun to earth. So the life sustained on the earth, right? Because this EM waves carries a energy from sun to earth. So the life sustained on the earth. Next point, in the region far from this source, the oscillation of the electric field and magnetic field are same in phase, right? So if the region is far from the source, then the oscillation of electric field and magnetic field are same in phase. But when, so if the region is far from the source, right? In this condition, the oscillation of electric and magnetic field having a same phase, right? Last point, the direction of E cross B, right? Vector product between electric field and magnetic field, E cross B, is in the direction of the propagation of EM waves, right? So here we can prove that if electric field, right, electric field is in the x-axis and magnetic field will be y-axis. So the unit vector of x-axis is I cap and unit vector of y-axis, that is j cap. So we know that I cross j, that is equals to k cap. So that is the unit vector of z-axis, right? So if I say electric field will be in x-axis, magnetic field will be in y-axis. So the unit vector for x-axis is I cap and for y-axis j cap. So we know that I cross j cap, that is equals to k cap, and k cap is the unit vector for z-axis. So the EM waves propagates in the z-axis, right? So the direction of E cross B is in the direction of propagation of EM waves. So here we can prove this thing, right? So friends, this is about the characteristics of the electromagnetic waves, right? So this is very important question for your examination, right? And last topic is of this chapter is the spectrum, right? So friends, I already shared the notes of this chapter number 8, right? So you have to prepare this spectrum, right? Different rays, right? So you have to prepare the spectrum and the different rays from the notes by yourself, right? Because it is very easy topic, you have to remember it thoroughly, right? So you have to remember about the different rays its range, its source, right? So you have to prepare about this spectrum and about the different rays by yourself, right? I already shared the notes to you, right? Okay friends, thank you.